Hello, everyone. My name is Jonah Gary, and I'm a student at Purdue University, and I'm here to present to y'all my instructional presentation. Now, what I'll be teaching you and instructing the audience how to do is how to derive a polynomial. Now, what's a polynomial? This is an example of a polynomial. It's basically just a term in math, and as Andy Hayes says on brilliant.org, is polynomials are an important part of the math language. So it's important to know what a polynomial is, and most of y'all probably already do. So this is a great example of it, 5x to the third plus 3x squared plus x plus 56. Now what we're going to do is we're going to derive this. Now, it is a very, very simple process to do this. So what you might need is a pen and a paper and a calculator. I can do this all in my head, but if this is your first time or you're not used to it, then a pencil and paper will definitely help. Calculator maybe, but this, at least from this equation, it'll be very easy mental math. It's important to know because most math classes after algebra, especially all calculus classes, use derivatives as just the baseline, and it can be applied to certain jobs. As learn.org states, calculus is used in many real-world situations. And for example, like engineering jobs, aeronautical jobs, any jobs that uses math and just equations to measure processes. Now, first step is to take a look at your problem and what you can. We already kind of did that. We already took a look at it's the 5x to the third plus 3x squared plus x plus 56. Now the basic process basic process is first you got to split them up by term. And so we'll start with 5x to the third because it's the first and it's about the same no matter what you do. So what you do is you can look at the coefficient, the variable, and the exponent. Now the coefficient is, as you can see, the blue, variables the green, and exponents the red. Now, what you need to do is extremely simple. It's basically just two steps. You multiply the exponent into the coefficient, and you subtract the exponent by 1. That's it. So after you do those processes, then you can get 15x squared. That is 15x squared is the derivative of 5x to the third. And so to do it on a polynomial is you just do it on every single variable. As you can see, that you'll just do those steps on every single one. As you see on the rest of the polynomial terms, it's 3x squared turns into 6x because it's 2 times 3 and 2 minus 1. Then it's 6x. That's very simple. And then x turns into 1 because there's an imaginary 1 in front of the x variable, and there's an imaginary 1 x to the first power. So you just do 1 times 1 and 1 minus 1. Now that minus 1 turns into 0, so you can just drop the x variable, and then you're just left with the coefficient of 1. Now, the special case is numbers without variables. It's very simple. It's just 0. It's just straight up 0. So you just drop the 56 or any of the numbers without a variable. You just drop that from your derivative. Now, the final answer turns into 15x squared plus 6x plus 1. What you need to avoid throughout this whole process is doing the math wrong, obviously, and that's pretty much the biggest thing that you can mess up on. Just follow the steps and don't do the math wrong. And always double check your calculations, especially if this is new to you. Just do the math correctly and you should be set, especially on these very simple polynomials. Now, in conclusion, once you get the technique down, it is very easy to replicate. As you can see, you could keep going. You could do 6x to the fourth, 6x to the fifth. You just do the multiplication and the subtraction, and that's it. And then you just end up with your derivative equation. Now, a derivative is, as Muhammad states on his website, SOS Math, the derivative is basically a measurement of the rate of change. And that's a whole nother thing. But right now, I just wanted to teach you guys how to do the process of turning a polynomial into their derivative equation. So thank you guys for listening.